All right, we'll start section 1.5 here, which is called transformations. Now at this point, we should be able to recognize the graphs of the basic functions. Remember the basic functions worksheet that we had talked about? That's those 8 functions, and we definitely need to know those, okay? Now sometimes we're asked to graph a function that's almost like one that we know how to graph. So it's almost like one of the basic functions. There's maybe something a little different about it. So suppose that, for example, I have the square function. The square function is a parabola centered at the origin facing upward. Okay, so you got y equals x squared. Now what if I take the parabola and I shift it down so many units? And they want us to state the new equation of the graph. Okay, well, to know what the new equation is, I have to be familiar with transformations. So let's take a look at some examples here. Now, what I'm doing in these examples is I'm giving you a function. I'll call it h of x, and then we'll look at another example. We'll call it k of x. And then based on what we're seeing here, we'll then write up a kind of a general statement about what's happening with that transformation. Now, in general, there are 3 kinds of transformations to know. There's shifting a graph, reflecting a graph, and then vertically stretching or smashing a graph. Okay? So all 3 are very important. So let's take a look at the first example here. Suppose I got the function h of x equals x squared minus 4, and we want to draw the graph of h. So we'll just use the table of numbers here. If I let x be, I can let x be anything, right? I'm not dividing by anything. There's no square roots or any other radicals, right? And those are the only 2 things that I'm looking at when it comes to domain at this point. So if I let x be 0, 0 minus 4 is negative 4, so there's 0, negative 4 on the graph. If I let x be 1, 1 minus 4 is negative 3. So 1, negative 3 would be on the graph. If I let x be negative 1 squared is 1, and 1 minus 4 is negative 3. So negative 1, negative 3 would be on the graph. If we let x be 2, 2 squared is 4, and 4 minus 4 is 0. So 2, 0 would be on the graph. And then if x is negative 2, negative 2 squared is 4, and 4 minus 4 is 0, so there's negative 2, 0. Okay, and now it looks like all I did was I shifted the graph of the square function down 4 units. Why did I shift down 4 units? Well, the negative 4 is what's causing that. Okay, so now what if I were to have y equals x squared plus 4? I'd shift this up 4 units. Okay, so in general, if you're just adding or subtracting a number to a function, you're going to shift it up or down that many units. Okay, here's another example. So what if I wanted to graph k of x? K of x is, now instead of having the minus 4 at the end, what if I essentially just replace x with x minus 4. So I want to have x minus 4 squared. Let's go ahead and graph that curve. Okay, and we'll just use the table of numbers, like I said. So if x is 0, 0 minus 4 is negative 4. Negative 4 squared is 16. 0, 16, that's off the scale that I've got there. That's fine, that sometimes happens, but that point would be there. Okay, if x is 1, 1 minus 4 is negative 3. Negative 3 squared is 9. So 1, 9 would be on the graph. That, again, is off the scale that we've got. Although that point would be there. If x is negative 1, negative 1 minus 4 is negative 5, and negative 5 squared is 25. So we'd be even further off the scale. You know, we at negative 125 is way out here. So while the domain is all real numbers, let's just focus on positives here going forward. If I let x be 2, 2 minus 4 is negative 2, and negative 2 squared is 4. So the point 2, 4, that point is on the graph. If we let x be 3, 3 minus 4 is negative 1. Negative 1 squared is 1. So there's the point 3, 1 on the graph. If we let x be 4, 4 minus 4 is 0. 0 squared is 0. So there's 4 is 0 on the graph. If we let x be 5, 5 minus 4 is 1. 1 squared is 1. So there's 5, 1 on the graph. And then if x is 6, 6 minus 4 is 2. 2 squared is 4. So there's the point 6, 4 on the graph. Okay, and I draw my parabola going through those points. Now, what happened to the basic function y equals x squared to get the graph of k of x? Well, it looks like all I did was I shifted y equals x squared to the right 4 units. Why did we go to the right 4 units? Well, the negative 4 is what's causing that. Okay, so what if I were to have x plus 4 squared? Well, I'm going to go to the left 4 units and graph that parabola. Okay, so let's, like, in general, here's what's happening. Okay, let's let y equal f of x be a basic function. So here I'm using the square function. Now what I'm going to say next is going to apply to any function, but and c is a real number. If I have the function and I add a number, okay, like I did right here. In general, if c is a positive number, you're going to shift up that many units. And then if c is a negative, like here c is negative 4, I'd shift down that many units. If c is 0, then I've done nothing to change the original function, right? Because I'm just adding 0. That's not going to change anything. Here's item 2. So what if I had replaced x with x plus a constant? That's really what I'm doing here. I'm replacing x squared with x minus 4, or x plus c squared. Okay, so and that's going to mean that I'm going to shift to the left or the right. Okay, you're going to go to the left that many units, c units, if c is a positive number. Okay, and you're going to go to the left, or excuse me, you're going to go to the right that many units if c is a negative number. So like right here, c is negative 4. And I'm supposed to go to the right 4 units from this graph there. Okay, if c is 0, I've done nothing to change the original graph. Okay, now this is kind of backwards from how I kind of tend to think about this. You know, I tend to think c positive, I go to the right, c negative, I go to the left, but it's switched on us. Okay, if c is positive, you're going to the left. If c is negative, like here c is negative 4, then I'm going to the right. Okay. Let's take a look at this example. So what if I had f of x equals x plus 3 squared minus 4? And we want to graph that by what we know about shifting. Okay, well, so let's see. What does the plus 3 and the minus 4 mean? Okay, the plus 3 means I'm going to have to take the graph of y equals x squared and go to the left 3 units, and then the minus 4 means I'll have to go down 4 units. Now, if you're only shifting a graph, it doesn't matter the order that you shift. So like I could go down 4 and to the left 3. All those points would still land at the same spot as going to the left 3 and then down 4. Okay, so 0 is 0, which would be on the original graph there. If I go to the left 3 and then down 4, that's going to put me at -3, -4. -3, -4 is called the vertex of the parabola. Okay, and we'll talk more about that in another section. The vertex is the highest or the lowest point. Okay. And then here's 1, 1. So if I'm going to the left 3 and then down 4, 1, 1 is going to be at -2, -3. There's that point. Okay. And here's the point -1, 1. When I go to the left 3 and then down 4, that would bring me to the point -4, -3. Okay? And here's the point 2, 4 on the original graph. So if I go to left 3 and then down 4, -2, let me go to left 3, that'd be at -1. And then I'm going down 4, that's going to put me at -1, 0. Okay. And here's the point -2, 4. So if I go to left 3 and then down 4, that point would land at -5, 0. Okay, so all these points are going to move. And then I can draw a parabola, you know, and that'd be a quick rough sketch of the graph of f of x. Okay, now something that I'll say again is notice how like if it's an advantage to know transformations, because if somebody is stuck point plotting, like I already know what the answer is without even drawing anything. I already know that I'm going to take the graph of y = x squared and go to left 3 and then down 4. Now that's huge over somebody who is stuck point plotting. Okay, so transformations are really important because it's like you already know the answer without even doing anything. Okay, keep that in mind. All right, so that's one transformation where you're shifting a graph. Okay, we'll talk about the other transformations here in the next couple of videos. So we'll go ahead and stop the video right here.